Who said it is Saturday, what, 3 August? I'm taking the watch off because I had some mic drops because of that. Recording on phones is so difficult. Sorry, vertical stream. Yeah, let's shut this drawer. Check. All right. Yeah, today was hectic. And the bay is trashed. Big time. So we're going to do a little late night diag just for you. Shop is closing down. It's 3 o'clock. But it's going to be just us for about the next 30 minutes to an hour while we look at this car. If we make good time, maybe we'll move on to another car. We'll see how the energy holds up. You know, like I slammed a energy drink. So I'm probably going to be talking some nonsense. Hopefully I don't do any more bad math. Last night I was doing some horrible bad math. Don't know how I did that, but I did it. All right, so here we have a 2014 Crosstrek, 251,000 miles on her. Customer says that they're on their second engine and second transmission. Don't know if that means that they've just put a junkyard engine in or they put a new short block in. Don't know the story on that. So here we go. We do have a recall line. It's a brake lamp switch. And that recall is really, really old. So that tells me that this thing has not been in a dealership for, golly, since like 2018. Because that's when that recall came out. Like that was a recall that came out during COVID. Right when COVID started. The brake lamp switch recall. Customer states horn's not working. Customer states when at a stop, cooling fans are not engaging. Okay. And the oil temp and the hill assist light is on. So here's the dealio: is typically it's 1 hour diag per concern. All right, that's what we all wish it would be, but you know sometimes hopefully the GoPro people aren't seeing this damn power cable in their way. I'm sorry if it is. Let me get it out of your feed. So yeah, in a perfect world, you would get charged 1 hour diag per concern, but no customer is going to want to come in here and pay $150 for every question. That is just absurd. How's that going to work for me, the technician? Well, basically, they could call, when you come in, when I talk to the advisor, this is how I'm handling it with the advisor. So the advisor writes up 3 lines, and they got 1 hour diag secured for these 3 concerns. Now, basically, I tell the advisor that, okay, so we're going to do a looky-loo diagnostic here, all right? And this is how I treat all the customers that come in with a whole bunch of concerns, but they don't want to pay an extravagant, they don't want to pay $150 an hour per concern. So we get like 1 hour, and I call it looky-loo diag, where I get an all scan, you get a visual, and based on my familiarization with the product, all right, I can normally figure these problems out lickety-damn split, okay? So it sounds like I'm hurting myself, but quite frankly, I already kind of have an idea of what the problems are. So I'm going to agree to these terms to just hopefully sell the work. If it's, when it comes, the main difference between like your full 1 hour diagnostics and looky-loo diagnostics. Okay, looky-loo diagnostics is I can do a basic function check with my scan tool. So you get a scan, I run a function check, I do an op check, and I make a deductive reasoning, and I'll tell the customer this is most likely what it is. If you want full confirmation, you're going to have to pay the full boat for me to go in, unplug something, do a system op check with meters, oscilloscopes, yada, yada, yada. Something like that, okay? That would be a 1 hour diag. But looky-loo diag, let me give you an example of one, okay? Customer's complaining that the horn doesn't work. So let's verify it here from the steering wheel. I'm pressing on the steering wheel. Nothing's working, okay? Whoops. All right, so concern, I press on the steering wheel, you don't get anything, the horn doesn't work. All right, well, a novice might say, oh, I'm going to start checking fuses, I'm going to get a wiring diagram. No, this is a modern vehicle. It has a key fob, lock, horn works. Okay, if this key fob talking to the keyless access control module talks to the DIU, shoots a signal down to the horn, I already know that everything all the way up is working. I got a problem with the roll connector in the steering column. That's a looky-loo diag right there. Okay, that's free. I don't charge for that diag. I'll tell the customer, hey, there's a 99.9% chance it's your roll lock connector. If you want confirmation, I am going to charge you diag to take apart your steering column and measure the resistance of your roll lock connector. Or you just want to put a part in there because this is what it always is. I'm familiar with this product. That's looky-loo diag, okay? Next, looky-loo diag. Customer states the cooling fans are not engaging. Okay. I'm going to pull up my fuse cover box here in the engine bay. I'm going to take out a 10 amp fuse and we're going to put it into the PDI slot, which is going to be, is it that one or that one? Okay, it's that one. So right here, I'm going to put it in that slot. See it? I install my fuse. Now, keep in mind, I did that with the car off. I locked myself out of the car. I'm going to put it in a key on, engine off. If you were to start the car, you would have a flashing check engine light, okay? That's a really common problem. People come into the shop and they say, oh my God, my check engine light's flashing. And that's because there was somebody who goes, oh, there's an empty fuse slot, and they put a fuse in there. All right, so let me bring you along and show you what's going on here. Vertical people, can you see what the hell's going on? Kind of, yeah. GoPro people, can you see what's going on? Yeah, good. Okay, look right here. See, the AC clutch is engaging. I'm going to take the mic off. You should be able to hear it. All right. We got relays clicking over here. All right, there you go. So this is a unique feature. This is a very unique feature to Subarus, okay? Now, starting in about 2000 and it's different for some. I think in about 2010, you were able to put the car into PDI mode and through the fuse box. Other models, you got the green connectors underneath the blower motor or underneath the steering column, okay? So you just got to look it up in the service manual. Okay, vertical stream, I'm going to take you along for the ride here. So in PDI mode, our cooling fans should be going high, low, high, low. They're not. I'm doing this all without a scan tool. Pretty cool, huh? Okay, GoPro people, stand by. Okay, GoPro people, here we go. Look at that. Our fans are moving. In PDI mode, those should be going high, low, high, low. That's a function check of the system. I have now confirmed that we do have a non-operational state of our cooling system. Ta-da! I'm going to use my 1 hour diag on that. Okay, I got the car. The car is key on, engine off right now. We're going to go ahead and do a scan. We're going to be using the King Bowling K10. All right, it's a wonderful little tool. I'm going to be truthful. King Bowling did give this to the channel for us to use. Basically, just because of the fact that there's confidentiality with the Subaru laptop. All right. And I don't want to lose the privileges that I have here on the channel of showing you how I do diagnostics, but I can't always show you the dealer laptop because you need to have a subscription and there's some confidential information on there, yada, yada, yada. I understand. So that's why we're using a third-party device instead of using the dealer source tool. Can we just set that there? Kind of. Oh, yeah. Hopefully everybody can see okay. Yeah, GoPro people, you're on fisheye lens. Okay, so we're going to do a smart scan here. And it's going to do a topology. Lot of codes, lot of codes. Now, keep in mind the topology scan is not always a 100% representation of your network layout. You should always double check that with your service manual to see the layout, but this is still very, very good information to see because it shows you the order in which this bus works, okay? Because that's how our computer network is set up. It's in a bus type topology. That's why I like to emphasize a lot for people that kind of underestimate us mechanics now. You still think we're knuckle draggers from the 80s and 90s? I'm telling you what, we're network programmers, we're network analysts, we're physicists, scientists. You got to know a lot about cars nowadays, okay? It's not like the old days where you can turn a couple of screws and bang on a carburetor and get the car to fire up. These cars have complicated systems now. So you got to have a little bit of science under your belt. So if you ever want to get into automotive, you know, pay attention in your math and pay attention in your science. You would be astonished how much science that I use every single day. All right. So I'm going to switch this over to system list because we just have a ton of crap in here. And transmission. Let's see what's going on there. All right, torque converter, clutch, pressure control, solenoid. Really popular code in that system, a P2762. I'm not going to waste my customer's 1 hour diag on that. 99% of the time, that's a control valve body, and it's worn out. So we're going to need new transmission fluid and a new control valve body. That's how I'm going to sell it to the customer. If the customer doesn't want to bite on the price of a control valve body and new fluid because they're questioning my diag, I'll say, well, we're going with the trend on that code, and if you don't trust it, you can always pay me my 1 hour diag to prove that maybe it's a harness problem or maybe it's something else with your system. But that's a looky-loo diag right there. I know from past experiences this is always related to a bad control valve buffer. Now, we have two engine computer scans right here. We have EOBD, and engine EGI. What's the difference between those two? Well, EOBD is my global OBD2, okay? And EGI, that's my factory side. All right, so if I click on here, I'm gonna get factory codes, and over here I'm gonna get global EOBD codes. About 80% of codes that are on the factory side are gonna be global OBDD codes, and then the last 20% is manufacturer specific. So if you have a tool that can only scan the global side, you might start seeing codes that have no description behind them, and they'll say something like manufacturer specific code, in which you would have to look it up in a service manual. This has all that preloaded. But let's just see what's on EOBD, and we got a lot of codes here. Okay. So arc neutral switch, circuit low. So right out the gate, if I see anything that says circuit low, circuit high, it's a circuit problem. It doesn't mean that it's a component problem. All right, I got a circuit problem. You always have to remember, check engine lights, they're not part numbers. Read the line verbatim. It says circuit, there's a problem there. Now, when codes have this input circuit low, there's always going to be one that it could also be called input circuit high. Circuit low is usually related to something shorted. Circuit high means there's an open circuit. And the reason why that is, traditionally, and I'm going to speak of automotive cars out there, okay? Because I understand that some vehicles, for some systems, may not follow this example perfectly, but this is a working example. The majority, I'm going to turn the car off because that clicking noise is getting on my nerves. It's hurting me from explaining things. Stand by. All right, turning the car off, and I'm going to take the PDI fuse out right now because I need to have a key on engine off. Hang on, guys. I just can't think while that thing's clicking and clicking. It's turn my blower motor off, turn my headlamps off so I don't fry this battery. Okay, let's go back. Let's back up. Circuit high, circuit low codes. All right. The majority of systems that work on a vehicle, they're working off of a 12-volt system or a 5-volt system. Understandably, there are some systems that could be on a 6-volt or 7-volt. Those are manufacturer specific. But the majority of automotive systems work on a 5-volt circuit or a 12-volt circuit. And let's use a 5-volt, for example. A 5-volt system will have an operating range of 0.5 volt to 4.5 volt. Okay, so those windows on the very edge of that 5 volts, that 4.5 to 5 volt, and that 0 to 0.5 volt, those voltage ranges are there for setting fault codes. And that's how the computer knows if you have a short or an open. All right, so let's use the MAP sensor over here. Okay, GoPro, pay attention. This MAP sensor is a 5-volt circuit. If I were to unplug it, there would be no load on that circuit. So that means that there's 5 volts hanging out on the end of this connector. The engine computer goes, hey, there's a circuit high condition. So if I see a circuit high on a mass airflow sensor, that means that I either have something unplugged or there's something broken internally. Ta-da! If I have a circuit low condition, that means that the engine computer has detected that there is a voltage reading on my mass airflow sensor between 0 volts and 0.5 volts, in which case I should be looking for a short, or there's something shorted internally. Ta-da! Now, how would I, if I had a mass airflow circuit low code that was on, how would I diagnose that really quick? Easy. I would put the key in I would put the vehicle in a key on, engine off condition. So that means I have power to all the systems, the engine's off. I'm going to be monitoring the codes on the car, and I'm just going to unplug this. If it generates a circuit high condition, then I know that all this wiring all the way to the computer is good. If I clear the codes and I plug this back in and it goes back to a circuit short or a circuit low, I know that there's an internal short on that sensor. That's how I test it. Okay? Deductive reasoning, because I understand the set conditions of the code. I did all that without a voltmeter. Now, moving along. So we got a circuit low on the input switch for our park neutral. We got a P0700 code. All that P0700 code says means is it just says look at your transmission computer. That's all it means. And that's an EOBD. That's a global engine code, because not all computers, not all scanners can look at transmissions. So it's an old, that's all I need. Okay, let's go to we got a P0140 O2 sensor circuit, no activity detected, bank 1 sensor 2. That's a new code to me. P2195 O2 sensor signal biased stuck lean. Okay, that's a familiar one. That basically means that the fuel trims, they've been riding in such a lean condition so much that the car just says, we think that this O2 sensor is just stuck in this condition, which can happen. You know, they get old, they get worn out, and they get stuck in that condition. P2196 says it's stuck rich. We're just looking at a dead bank 1 sensor. So this vehicle uses a air-fuel ratio sensor. I'm going to be recommending new O2 sensors, just primarily based on the age of the vehicle. They just go bad. Okay, more O2 sensor circuit codes here. Torque converter, clutch. Yeah, so this thing, right out the gate, I'm going to be telling customer we have oxygen sensor codes that are being set for stuck rich, stuck lean. More than likely, you just have worn out O2 sensors. If you want me to do further diagnostics, I can charge you diag, or you can take my word for it based on my experiences with this platform. I see that. I know that that's the contributing problem. Same thing goes for these codes for the transmission control module, the P2762. Anything related to a solenoid, hey, the solenoids are worn out. You need to just get a new transmission control valve body. All right, going into the factory side of the engine computer, seeing the same codes, not a problem there. Brake control module, what's going on there? VDC interrupted for engine convenience. Basically, that's a code that just says, hey, there was an engine code that was set, so I'm going to deactivate myself, so that way you don't get traction control, you don't get anti-lock brakes, because if the engine computer doesn't know what's going on, I can't rely on its inputs to make my judgment good. So it's deactivating its safety systems until it has a known good reading from the engine computer. All vehicles are set up like this now. Okay, if you get a check engine light for anything, that means that there's bad judgment calls being made by the engine, and all the other sub-platforms depend on a good working engine in order for those advanced safety features to work, like traction control, anti-lock brakes, so on and so forth. We have a code for the brake light switch, 1531. This car is here for a recall for that, so we'll be taking care of that. So that's going to get replaced regardless. Tire pressure says we got low tire pressure all the way around. With the mileage and the age on this vehicle, these TPMS sensors could just be dead, but I can do a quick scan with my tire pressure monitor. My favorite one to use right here is the Tire Go 608. You can always catch it on sale on the Amazon store for like 99 bucks. I love this thing. You get free updates. So anytime somebody complains about a tire light on and they just put air in their tires, I can just scan this thing, and if it don't talk to it, I'll be like, sensor's dead. You need a sensor. I'm not even going to charge you Diag for that because that takes like 3 seconds to do. Now, if you argue with me, I'll charge you Diag. Let's see what's going on in our body control. Okay, combo meter communication loss. Lost communication with HVAC control module. Can high counter abnormal. Oh, that's not good. Okay, we got some not so good codes right there. That can be related to a engine battery that is just wearing out, because if we're getting bad voltage or unstable voltage coming out of our battery, that can make our engine control modules and all the other modules not respond correctly, which can give us some CAN bus problems. I'll also be looking for LEDs in the vehicle. Subaru hate LEDs. I'm going to be straight up. They hate LEDs unless they come from the factory with LEDs. Those LEDs are okay. But if you have an incandescent bulb lighting system and you put LEDs in, you're going to get CAN bus communication codes every single time. And I've seen some engine computers and some BIUs just get fried because of it. I have a whole electrical class where I explain that. I went through a diagnostic on a Forester with you guys live, and this guy was complaining that his car was turning off while driving on the highway. Scary as hell. And he had LEDs from headlamps to tail lamps to interior, and he didn't believe me. We took them all out, put incandescent bulbs in. I'm like, well, you know, your car works. And I explained the whole reason of why that happens. So we've been down that road. Power steering. Wow, the resolver. We're getting some high mileage error codes here. What's in the combo meter? Power supply error detection. Battery. So a lot of that tells me that this little Walmart battery, she's pooping out. We'll also do a quick little alternator test to make sure that the alternator doesn't have a leaky diode in it too. In the meantime, let's go ahead and focus diagnostics on our cooling fans, okay? We need to find out why the cooling fans are not working appropriately. Let me get my water too. Running out of breath. If anybody's got questions and you're putting them up in chat and I'm not answering them right away, I'm very sorry. This is going to be like a watch me work kind of lecture, but I will scrub the chat at the very end. So if you ask a question and you feel like you're not getting the attention that you deserve and you leave because of it, check back in at the end of the videos. I'll probably answer it, okay? Or somebody in chat might answer it for you. I have a lot of very knowledgeable people that like to hang out. Oh, yeah. Okay, so let's do the obvious really quick. I'm going to make sure that the fans are plugged in. And one is plugged in, the other one's plugged in. That was easy. Now let's come over here. And let's look at my fuse chart. Again, another reason why I like working on my Subarus is because they label all the fuses and the relays right here in the lid. Ford don't do that. I hated working with Ford. Always had to look that stuff up. And And that's why I always argued for Diag, because I'll be like, man, I got to stop and look things up. I'm charging you for that because Ford doesn't make it convenient. Subaru makes it convenient. They put it all under the lid. Okay, so I can see right here, I got a relay for a sub-fan relay, and then I got a main fan relay. And I know from off the top of my head that they pull power from these slow blow fuses over here. So you guys paying attention? Follow the camera. We're over here now. Okay. And GoPro people, pay attention. We're right here. So these big square fuses right here, these are called slow blow fuses. You might see them labeled as SB. Basically, they're special fuses that are designed for inrush current, and they won't blow if a heavier load comes through them. So for instance, like this one's a 50 amp fuse, and when the circuit initially kicks on, it might initially pull 60 or 65 amps. This is designed to take that inrush current and not blow. As opposed to these blade fuses, they're more sensitive, okay? They will blow with inrush current. So if you've ever had one of those situations where you have like a whole bunch of gadgets plugged into your cigarette lighter, you know, you got your police scanner, you got your radar detector, your CB radio, your accent lighting, and every time you turn your car on, the fuse blows through that circuit, and you go, I don't understand. These devices only pull 5 amps total, and it's a 10 amp circuit. It shouldn't be doing that. Something's wrong with my car. No, when those devices initially power on, they might pull double the amperage, and then they taper down. It's a really common theme that I see with people who have a lot of gadgets plugged into that accessory outlet. That's why you only get one plug, all right? Because we're compensating for inrush current. All right, so I'm going to be looking here through these glass ports, and I'm just going to be making sure that these all look intact. Sometimes they melt and sometimes they crack, so you really want to look closely for cracking. It can be kind of tricky. They're all visibly looking good, so the next course of action is to go to our relays right here, and let's see if we got any power on our relays. Let me fetch my relay puller. And hopefully my relay puller isn't sitting somewhere random. Because that happens sometimes, guys. Okay, I don't see it there. Is it in this drawer? Aha, I found her. Yay! Okie doke. So double check what I'm going to be looking at here. Main fan, sub fan. All right. So these are my favorite relay pullers right here. They're Blue Point from the Snap-on truck. Part number is Yankee Alpha 9811. All right. Now the reason why I like these is they grab the relays diagonally, and they have this nice little double step right here, so I can get a good pinch on it, and I don't crush it. Too many times I've seen people like just destroy relays that didn't need to be destroyed because someone's already frigged this one up and they broke it. Pull the cap right off. Someone's already been trying to diagnose this cooling fan thing. You can see the plier marks right there. think this one's gonna get boogered up trying to come out, which I'm not gonna be happy with. Unless you play nice. We might lose this one, folks. I don't want to lose her, but we might. There we go. That happens when people plier these things. They get all boogered up. All right, she's up. Someone's been playing around in there. See, she's got already a bent pen. That's why she didn't want to come out nice. Doubt that's going to want to go back together. But if you've ever wanted to know what's inside of a relay, this is it. Okay? We got power right here. This is our coil. And we got a signal wire. And when the circuit's complete, electricity flows through this coil right here, makes an electromagnet. And there's a little flapper paddle right here. Okay? It either gets pulled to one side or it gets pulled to the other side. Now, traditionally, these are usually biased to one direction. So in this particular example, we're biased right here on this leg. And then when the circuit closes, it switches, or when this coil is energized, it opens up a whole nother circuit. So some relays will activate a single circuit. This one is when the relay's in an off position, it's leaving one circuit intact, but then when it's turned on, it activates another circuit. See, this relay only controls one circuit. So when the relay's off, the circuit's open, and when the relay's on, the circuit's closed. There we go. See, that was our, so this one right here, this is our main fan relay. So in its natural position, one fan comes on. And then when it's commanded to, when it's commanded for a overheat condition or to like a super cool down, then it'll go into a high-speed mode and it can turn on, in which case it might also bring on the subfan. It's a really complicated circuit to explain without diagrams, but overall, this relay's foobar. Someone's been dorking around in here. So that's always fun. I'm gonna take a closer look and make sure that nobody hasn't tried to screw these pins up, because I see that a lot from shade tree mechanics. They shove wires in there and try to just short the relay circuit so that the fans are always on. I've had a couple cars come in like that, where the cars were, they weren't getting enough horsepower. The customers were always complaining about lack of power. And what I found was the relays were dead. So the relays weren't working. And when I pulled up the relay, I found wire shorting the connections. So the fans were always on. And because the fans were always on, the car was always cooling down and the car never got to operating temperature. And because it was always being cooled down, the engine was pulling timing. And when the engine pulls timing, the flame front is bigger, And it's doing that to try and heat up the coolant. So the car is always trying to heat itself up. And when you retard timing, you don't have as much power. I says, there's your problem. We need to take this garbage out, put in some working relays, bada bing, bada boom. Hopefully that didn't fry your oxygen sensors or melt your catalytic. But that's what I see at a lot of little five and dime mom and pop shops. They don't want to pay for these relays because these are 30, 40 bucks a piece. So they'll just short out the circuit and be like, car doesn't overheat, it drives, it's good, ship it. And because they buy all their cars from auction, they'll just blame it on the auction and be like, well, you can pay us to fix it. Anyhow, where are we going with this then? Oh yeah, let's get a test light. Get a test light. Let's check out GoPro chat, see how GoPro chat's doing. Juan's in here. Bass says, this is neat. Yeah, I try to make it fun. Rock 962,000 says, my body 3D printed some brake light tools. Yeah, that's sweet. I think I have at least 2 or 3 of those special tools because I've gotten under cars and I found them stuck there from previous shops who left them there. Lucky me. Let's take a look at vertical chat, see how vertical chat's doing. Johnson says, good to know. So he's learning something here. Michael says he uses fingers for fuses. Ooh. He uses paper clips. What model is this? This is a 2014 Crosstrek. Raw OZ is calling out new fans. Big Crack, that device he has, can it tune up speed on car? I can use bidirectional support and I can control the RPMs of the engine up to 2000 RPM if I was doing something for diagnostics. Looks like Juan's trying to help somebody here in chat. Yeah, well, you know, everyone's kind of talking about the high mileage of the vehicle. You know, some people got high mileage vehicles, and I'm not going to discourage them from driving high mileage vehicles. They just need somebody to help them out. That's all. Obviously, when you get into a high mileage vehicle, you have a higher level of component failure. So let's go ahead, because we're going to be testing our fans here, I'm going to put my PDI fuse back in. And I'm going to have to cycle the key power here. There we go. I almost started the car by accident. It's okay. All right, so we're going to be hearing that fan clutch click on and click off the entire time. That's going to be distracting for me, so I'm just going to disconnect it. Using my test light here. This is just a basic test light with an incandescent bulb. I prefer these over those ones that have the little digit readout in them. Basically because they're better for these type of systems. Obviously, I would never use this on a computer system, but this is just me. This clamp is getting kind of worn out. Then get a better grip on this negative terminal. There we go. It's not going to fall off. When you're using a test light, you always check, make sure it works, because the last thing you want to do is be scrubbing a panel and be like, man, there's no power here, and then find out you got a dead bulb. Also, another pro tip too is I like to always bend the tip just a little bit with a pair of pliers, so that way I'm not always trying to hover it. I can kind of hold it a little bit off to the side, which just makes it easier to work. So let's go ahead and see what we got going here. Do we have powers and grounds on these relays? Okay, so our subfan circuit here. Yeah, subfan. All right, I got power. And then these, I got power. Good. I got power and I got power, so my subfan circuit works. This circuit's dead. There's power there. No power there. No power there. So that sucks. So only I got both legs working on my subfan circuit, so that's good. But my main fan circuit, I only have one circuit working. The other circuit, dead. So now I do want to reference a wiring diagram, and I want to find out which one of these big slow blow fuses is controlling my fan, if it's not labeled here, because it might be. Okay, I see my subfan fuse is at 25. I got my orientation. Here's my main. Oh, sheesh. Look at that. There's my main fan relay right there. Someone's been dorking around in this thing, and it's hot trash. See? You don't get. Look at that. Come on. I hope this person didn't pay money for someone to break his stuff. That's just ridiculous. Okay. All right, cool. So I got power on that leg. Most likely, we got dead relays, and they're going to have to be replaced regardless because they're busted. Here's our main fan. Main fan is a blade fuse right here. Let's check for power on it. And I always, when I'm checking for power on my fuses, I like doing the test light versus pulling them out and looking at them. Why? Because I want to look at the circuit in the condition that it came in, okay? There's too many times where you pull out a fuse to look at it and you go, hey, that fuse is good. Then you put the fuse back in, and all of a sudden it comes back alive. Okay, so I call it contaminating the crime scene. Touch one leg, no power. Touch the other leg, power. I should have power on both sides. That's an open circuit right there. There's a relay puller, and see if I have the strength to pinch it. These little plastic ones suck. Okay. Look at that right there. Blown fuse. Now, when I'm looking at this blown fuse, I want to look and see how it blew. You can see a big black mark in there. That means that it arced. And when it arcs like that, that means that something was shorted out. So there was a high rush of current that came in there. If it looked like it melted, then that means that something was overloading the circuit very, very slowly, like a frog in water scenario, in which case you want to make that note to the customer. You want to say, hey, like, we have a blown fuse. It doesn't look like it arced, so there was like a direct short, like this one you just looked at. It looked like there was a constant overloading of the circuit, very slow creeping up. So because what you want to understand is this is a 25 amp circuit, but you know it might be 26 amps getting pulled through it. If it creeps up like that, the circuit can kind of take it a little bit, but eventually the heat will melt the fuse out, if that makes sense. In which case, you would want to tell the customer that you would want to do a amperage test of the circuit. That might cost a little bit of diagnostics depending on the complication of the circuit. This one's easy because right here I know exactly what controls it. There's no other influencers that could be tapped into it. Obviously, if this is a cabin fuse and the person has a whole bunch of aftermarket lighting and stuff like that, I would be charging money for that, because I'd be like, you could be tapped into anything. But this fuse runs a fan circuit. I have the equipment to do an inline amp test of this, so I could analyze it. And I would just pretty much just let the car run outside my bay for a little bit and check it out. So we got a blown fuse, and we have some messed up relays. So I have my parts department's closed. We're working after hours. The customer's not here. They just towed it in, dropped it off. So what I'm going to have to be telling the customer right now is we're going to replace a fuse. We're going to replace all these fan relays because they're frigged up. And then we're going to reassess the situation. If the fans don't come on with all new relays and a fuse when I put it back in PDI mode, then we're going to be unplugging our fans and make sure that we have power and ground there. Can we do anything right now to assess and see if something is going on? Because I don't have a spare main fan relay. I might have some spare fan relays. And I think I got something. Hang on. I think I might have enough. I have equipment to do a bypass. Okay. I can do a bypass on a circuit, but this is a lot of relays all in the same circuit, and this is kind of new to me, bypassing. So let's check her out. Let's see what I can do. Is it this suitcase? It's going to have my bypasses in it. Okay, there's no bypasses in there. It might be this one. Okay, there's bypasses in here. Let's see how many circuits we can bypass. B&W. No. So this one might work in here. Yep. I can put that one there for my main fan. I even broke the damn holder for it. Good God, guy. I can't even get my tool in there because it's all warped and stuff. Where did I put that big? What is it? Do a little dimensional check here. Let's presume that this can still function even though it's got a broken lid. All right. Put that in there. Because even then, okay, it's still clicking. That's good. She's a clicking. Let's get the fuse buddy on fuse 25. All right. Okay. Or the short buddy. I like, that's what it's called, the short buddy. Really cool tool. This is made by Electronic Specialties. Runs about $70 if you catch it on sale. Really, really nice to have. So this is going to be an electronic fuse, okay? I'm going to set it up for 25 amps. Plug it in here. Take that out. We don't need that. We need a 25 amp fuse, which we're going to use the one out of the customer's fuse box right here. So if this device senses an overload, it's going to kill the circuit, and we're going to hear a beep, beep, beep. Okay, so with that in there right now, let's check what's going on here. That lights up. See? And then it's going to reset itself. All right. Might be something messed up down there. Don't want to lose those wires. Don't want that one. Don't want that one. So let's get my controller here. I'm kind of excited. I don't get to play with this guy too much. So this is a fantastic tool. If you're dealing with relay circuits, this is a tool called the U-Activate. It's sold through AES Wave. And if you're interested in getting one, I recommend that you just go straight up for the master kit. And the reason why you want the master kit is because it's going to come with pre-wired connectors for every possible relay circuit. And then it's going to allow me to manually override and look at everything. I plug my adapter in there, then I plug my controller in here, like that, and now I can turn my relays on and off, and I can even hook up an amp clamp here, and I can measure the amperage through it. This is a fantastic device. So right now, power's coming through. That's good. So it's trying to do something. That's good to know. Can we bench check this fuse and see if it works? Yeah. There's a thing called a relay tester, and I really don't like the relay tester, okay? Do I have it available? Because I usually only have, I bought this thing about 15 years ago, and I thought it was going to be the coolest thing since sliced bread, and all it did was just get me in trouble. To the point to where I just keep it around now, because it's a worthless friggin' tool. But I use it just mainly to demonstrate to people what a worthless tool it is and don't get suckered into buying it. Okay, I don't have it readily available, and I don't want to find it in my toolbox. That'll be a huge delay and demonstration. I am going to get a jumper here. Where's my jumper? Is this a good jumper? No, that's not a good jumper. I want my Asian jumper kit. That's my domestic jumper kit. Yes. Okay. This is by Lyle Tools, rebranded by Mac, of course. But I only bought it through Mac because Mac gives me lifetime warranty on these. And they were on sale. Like, I got the Asian and the domestic version of these for cost. Anywho, this is the jumper tester here. So finding the right pin configuration. What the hell? It allows me to go in, and then I have all these test pin points, and I can test the circuit live. This is a 3 and 2. Maybe it was in the other kit. Is that it? That's it. Haha. I didn't put it back in the box. I must be using it. So here we go. I can put this relay in there. And set it up like that. This is kind of, there we go. Yeah, someone's been smashing pins in there. Okay, I can feel this thing clicking. That's good. May not mean that power is getting sent through it. How you doing, vertical people? Missing all the action on that fuse panel, huh? Sorry. I must have bumped the Kurt by accident. Let's get some of this out of the way. Let's go in. Ooh. Oh, here's something fun. Let's do a tangent really quick. Check this out. Look at my upper radiator hose here. Come on, vertical stream, pay attention. So the hose right here is starting to collapse. Can you see this? Let me bring you in closer, vertical stream, so you can see it. Look at this radiator hose right here. The car was warm about an hour ago, but now it's cooling down, and this is collapsing. That shouldn't do that. That's not good. Hook you back up. GoPro people, here you go. So you can see. Look at that hose collapsing. That hose should not collapse. That means that there's a vacuum in the coolant system somewhere. How much you want to bet this cap is dead? It's probably going to be broken on the inside. Maybe the valve is broken, or the gasket is swollen and it can't do its job. And look at all that crud that's in there. This is a bad radiator cap. I don't even have to get my tester. And now this hose has opened up. See, as this cap has two functions, okay? It bleeds pressure over to the expansion tank, and then when it cools down, it has another gauge that gets pulled down so it can siphon fluid through. I'm going to bet dollars to donuts that whoever did this guy's engine work, okay, whether they put in a used engine or they did a head gasket job, they didn't replace this. Folks, you do an engine, give the guy a new radiator cap. Come on, these things are $5-10 a piece. That radiator cap's dead. Look, it doesn't even want to go back in because this doesn't even want to go in there. This is swollen up full of oil. I'm gonna now I want to say 100% that this car probably had blown head gaskets. There was coolant and oil mixing in the radiator system, and this cap sucked up all this oil, swelled up the seals, and it's failed. So he needs a radiator cap for sure. Let me wash this garbage off my hands. That was stupid of me to put it in there. Bad, 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 bad. And you know, I don't really want to I really don't like punching down on other shops, folks. But, you know, that's why you want to go to a reputable shop that has people with tenure there. They've been working on it. You really don't want to go to a shop that just has a bunch of techs that bounce around, okay? Because this is something that I teach, okay? You do an engine job, you put a new radiator cap on every single time. If I put a radiator in, you get a new radiator cap. If I do a coolant flush service, you get a new radiator cap. Why? Because that cap has been living closed and sealed on that system for 5 years, 50,000 miles, 100,000 miles. It's never been disturbed. I have now just disturbed it. Do I really want to risk a multi-$1,000 engine job over a $10 part? No, I do not. So anytime I touch the coolant system, if that cap gets disturbed, you get a new cap every single time. And radiator cap testers, yeah, you could be like, you should just use a radiator cap tester and that'll confirm it. Yeah, well, it might work again, but it's a 10-year-old cap. It's $10. If I have to pay for it through my shop expense, I don't care, because that's going to prevent me and my shop from eating a multi-$1,000 engine over a stupid little part. And when you do this professionally, you have to make those calls as they are. All right, so I'm going to come over here and I'm going to disconnect this fan. See what's going on. I need my little disconnect tool. Look at that. Pocket pry bar. Okay, so I got one fan disconnected. Let's get to the other fan. And this tank is going to have to come out of the way. Another, oh God, I'm really fearful of this car right now, and I'm putting gloves on. Okay, so again, I need to talk to this customer and I need to get some feedback on what's been going on. Again, you're putting an engine in, you're doing an engine repair, whatever the scenario is. Clean up every evidence of what was previously there. This hose right here, the reason why this dude has it zip tied on here, which it doesn't come with a zip tie from the factory, let alone it doesn't even have a clamp. This hose is swollen full of oil because at one time, or maybe now, this coolant system had oil mixed in it. And that overflowed into this expansion tank, and which is why it looks like garbage in there, okay? This hose sucked up all that oil. That's why this hose does not want to go in there. It's swollen. When I'm inspecting Subarus, I'm always looking at this hose, okay? And if I see that swelling starting to happen, I let the customer know. Or I ask them, I interview them. Have you ever had your engine serviced for head gaskets? Yes or no? No. Okay. I see this as an early identifier. You might have some oil mixing in your coolant. Oh my God. Is everything okay? I'm like, no, we can do tests to check the integrity of your engine, but you know, you might be having some problems. And then I look at their 9 times out of 10 when I pull their oil maintenance history based on a Carfax report or interviewing the customer. Here's what's happened. I just bought the car. Okay, well, the previous owner didn't do their oil changes. They had 10,000 mile intervals, so you have blown head gaskets. Damn. Or I tell the owner, you've never been to my shop. Do you have, you know, when you get the oil changed? Oh, my husband does everything. Does your husband have a journal of how he's worked on this car? No, I just trust him to do it. That's not an answer. All right, so now I need a test light. I need something. So, yeah, folks, when you're looking at buying a used car, get a Carfax. Look for maintenance services and make sure that all those oil changes have been done accordingly. Too many people are just losing hard. They're just losing really, really bad. You get a car, and then within 6 months, you need head gaskets. All right, so this is one of my little homemade test lights. This is a 5 amp test light. This is plenty of load on the circuit to see if we got power down there. I'm just going to plug it right into this connector. Doesn't matter which side goes where. Okay, because as soon as I complete the circuit, this light should be clicking on and clicking off. Let's see if I can get in there. Oh, all right, let's try and back probe it. There we go. Nothing's lighting up. You know what? I broke my first rule. What did I say? Test your light. I need some ground. The leads are too short. Will it ground on this? There we go. Yeah, okay, so my light bulb works. That's good. So you're not going to see it too clearly because I'm a little bit off screen. I'll bring you in a second. I'm just going to try and make sure that I get a good... Can't see what I'm doing. Need a work light. So I've unplugged the fan, and what I'm trying to do right now is put this. Oh yeah, someone's been doing the hokey pokey in here, frickin' hardcore. Golly. Golly, friend. There's just a damaged circuit, man. I'm just gonna give this dude all kinds of problems. Okay, so vertical, come on over here. And GoPro, you should still be in view because you got the fisheye. Again, guys, if you're on the vertical and you want a better picture of things, go to the main channel. We got the GoPro up. You can see a lot more information, and it's in 4K. Okay, so the light bulb's plugged into that fan circuit. There's no power there. So I got something possibly wrong in my front engine harness. Not good. I haven't even looked at a wiring diagram. So let's come back over here. Let's do it to the same side. I'm not front probing, I'm back probing. Whoop! Okay, that circuit works. That's good. I like that. So one fan works, the other fan doesn't. This side, if I'm correct, this is our main fan, this is our sub fan, and we were questioning our sub fan relay. So I'm going to unplug that. So there's power there. That means that that fan's dead for sure. Yes, somebody in chat got it right early on, but we wanted to prove it. Let's put our light bulb back in on this other circuit. Okay, so now we're going to be troubleshooting our sub fan. All right. Got my light bulb up here. Vertical, can you see what's going on? There we go. Vertical, the light bulb's right there. We're going to try and turn it on. And we're going to try and do it. With this. Do that. Okay. So I'm using the U activate. That's why it wasn't working, guys. I forgot that I had put in this isolation tester. So only one leg of the fan circuit was working correctly. My bad. That's why you should always be familiar with your diagnostic tools. So this can only energize one side of that relay at a time. So I know that my circuit here is good. I know that right now the circuit over there is good. Okay. This customer needs new fan relays and it needs new fan motors. That's it. Diagnostics. Now, did that take a little while? Yes, it did, but that's because I was going slow and I was working with you guys, and I want you to see how all this does. You know, realistically, I would have figured this out a lot faster, but I wanted to show you my tools. I like showing off my tools, and I like explaining things for y'all. The car is still going to need a heavy multi-point inspection, and we'll see where things go. Hey, look, a souvenir. So that was fun, wasn't it? Hey, let's scrub through some chat and talk to some people. Matt wants to know why relays and fans at the same time. Well, okay, let's backtrack here. Maybe you missed it in the beginning, but we came in here to inspect our relays, and the relays, somebody took pliers to them and they broke them. Okay, there's plier marks all around here. This is busted. This is busted. So I'm not going to guarantee my work unless the customer wants to replace these relays with ones that aren't dorked up from pliers, and then overall he's going to need new fan motors. That's the long and the short of it. So if this guy took it to another shop for diagnostics, he can go back to that shop and he can yell at them for breaking his relays because whoever was in there, yada yada yada, just plier banged this car to death. Then I'm going to have to put some liquid electrical tape. It does exist, yes. I'm going to liquid electrical tape all those connectors down there for the main and the subfan because whoever was in there did the hokey pokey with a test light, okay? And all those connectors down there are just dorked up. But yeah, that's why he needs new relays for his fans. Is whoever did the circuit diagnostic testing of this area right here broke everything. Okay, Matt says, so the main problem is fans, but you're suggesting relays, understandably. Main problem is fans. I'm recommending relays in addition because there is damage from the last technician or person who went in here and tried to pull relays out. They broke the covers. They broke the pins. He's just going to need them as a consequence. I hope that makes sense. Matt says, use the power probe on the fans to make sure that the fans are working. Sure, we can put a power probe on there. Let's see if we can turn them on. How about that? Matt likes power probe. I have a power probe. Yes, I do. I don't know if anybody else has seen a power probe. That's why I'm just going to pop this fan out really quick because it does come out pretty easy. That way you can see what I'm doing. But I would normally just do this underneath the cover. There's our fan. And we'll power probe right up here to this connector. Let's go get Mr. Power Probe. Okay. We're going to need a adapter. I think I got one around here somewhere. Need that one for sure. And will that one work? Let me see. No, that one won't work. Yeah, I guess this will work. My power probe is in pieces right now because I use it for other tests. I'll be using the Power Probe 4. I like the Power Probe 4 just because it has other features on there that I find it pretty handy. Connect our light. Let's get all our gadgets off. Hook this baby up to power. Plug her in. Oh, I grabbed the wrong ground thing. Oops. This goes to a different tool. That's the short buddy. There she is. Maybe everything I need is in that case. Everything I need is not in that case. Okie dokie. It wants to be mean. I guess we can just use this. Oh, can we use this? Let's try this. Sometimes I lose my bits and pieces because I teach a class and everyone has a thought experiment and I humor that idea. So I take things apart and all my tools so they don't go back in the same spot. So I'm very sorry for this. We will get her straightened out pretty quick. Is that the wire I want? Yeah, that's the wire I want right there. Okay. So here's our ground. And we'll connect to that run. And plug that in there. Use this as a test wire. I thought I brought over a Proby. Why did I not bring a Proby? I probably set it down and then walked away. Oh. I'll just use this one. Okay. Let's see. Ooh. Hey, the fan turns on. Matt, what do you know? So, Matt, what did we learn? Wait a sec. This is... Do we have our bypass set up? Yeah, we do. Let's go over here to this other one. I know what's going on. You got me, Matt. You got me. I'm going to pull out this other fan really quick. Did I set up my test room? Well, I do have broken relays, and I thought I had my tester set up wrong. I know what's going on here. Okay, let's work this experiment on this fan now. And let's backpedal and find out how I set up my test wrong. Interesting. So, why is that happening? What went wrong with that? Well, for starters, I do have broken relays up there, and I'm running a lot of bypasses. So I might have set up my test wrong when I was setting up my bypasses. So my main works, my main fan relay works. Set my experiment up correctly here. Let's go up here. Power, no ground. Nothing. I got ground and no power. But I also got a dorked up situation here. Let me get my bypass thing set up again. Yeah. Might have had a test equipment problem here. Too many things going at once, but hey, it's live. And Matt, thank you for asking questions. Okay, with the bypass in, we lost our power and ground over here. Well, and what's happening over here? We got ground. We don't got power. Think, McFly, think. Oh, my 25. Hey, this fuse came out. So let's put that back in. Too many tests set up at once. Trying to answer too many questions. Sorry, guys. Okay, hey. All right. That's working now. That's good. Now when I turn this on, is this one dead? Hey, all right, okay, all right. So that was a failure on my point. Just playing around with too much test equipment, answering questions, got the whole thing fucked up. Matt, I owe you a lunch, man. Even the best of us can make simple mistakes. Plug her back in. Everything should be nice and peachy. All right, fan came back to life. Make sure your dick beaters aren't in there. Up. And it turned off. Did we just blow the fuse? No, we didn't blow the fuse. Huh. Well, it worked for a second. What is happening? All right, let's get her disconnected again. Ah, I see. Okay. The connector's messed up. Very cool. Ah, got it wedged in there wrong. There we go. Okay. So, what's wrong with our pigtail? I hate coolant. I hate coolant. I hate coolant. Force that back on. You just need a new one. Okay, guys, here we go. One more time for the show. trying to seat it in the radiator correctly. All right, there we go. We have a broken harness right here at this fan connection. When I got it plugged in normally. Now, where is that? There it is, right there. How can I manipulate it in this tight space? There we go. Okay, you guys can probably hear it with the microphone kicking on and off. Something's wrong with the pin tension. Let's check this out. Let's look at these terminals a little bit closer. I don't see any green crusties, but we might have something bad right here. Okay. Let's do some wire piercing. There's already wire piercing damage on here, and I'm going to fix my wire piercing damage anyways, so don't hate me. Let's find out which one of these runs is the problem. Oh, my proby tip. There it is. Clamping on blue. Yeah, there's like half an ohm of resistance there on this blue run. Yeah, the black one is. And that one's a little bit better. Let's check the kind of the same. So not teabag. Let's go down here to the connector side. Make sure that, oh, give me my, what's beeping? Oh no, GoPro, why'd you power off? You're supposed to be on backup power. Oh, your battery's just dead. No warning there. That sucks. Okay. Well, if you're on the GoPro feed, you're tits out of luck. Have we been going that long? All right. So it's just vertical for now. Let's see what we got going on here. We got the hokey pokey. Oh, and the terminals are spread. What? Yeah. Holy crap. That might be it. Double dinners for you, Matt. We'll get Matt a steak dinner for this one. So hopefully you guys can see it. Can I enhance? We can enhance. And a flashlight. So that somebody front probed the hell out of that with a test light, screwed up the terminal tension. So I'll have to depin this connector and reset the terminals. Let's backtrack this whole theory now, Matt. Matt's a champ. We're gonna give Matt a lot of credit here. That's what you get for asking questions. I think everything was related to this fuse. Here we go. Here's my Dexter blood spattered pattern analysis. Fuse blows, and somebody goes swapping relays. Then somebody breaks relays, makes the problem worse, comes down here, starts doing the hokey pokey, and tried to front probe with a voltmeter or maybe a test light, spread the terminals, made the problem worse. And this is just a compounding problem of people going in here trying to fix the problem. So, Matt, we have good fans. That's going to save the customer money. You save the customer a lot of money. That would have made me look dumb. Thank you for helping me out with that and asking that. Definitely going to need the relays from the damage, need a fuse, and we're going to have to fix these plugs here. Now, these plugs can be refitted. I can tear them down. It'll be a tight fit because we don't sell pigtails for Subaru, but I can take this apart and I can fix the pin tension. So I'll have to depin this connector here and over there. Golly. Kudos to Matt. Good job, Matt. Yeah, sorry, Matt. I can't keep up with the chat and do diagnose and talk at the same time. Nero says just bypass it. Like my bosses don't like it when I do bypasses, even with customer consent. It's just an insurance thing. They don't like they like just selling solid fixes, but they'll allow me to sell the repair to depin the terminal and put new pin crimps in there. Matt says I lost the other live. Yep. The GoPro only has about a 3-hour battery. How long have we been going? A couple hours now. Maybe that didn't have a full charge. Maybe it didn't. So I didn't check my battery. I have this big backup battery, but I was running it on the phone. So my bad. But hey, it's good having you on the channel, Matt. Michael's asking if it's a cross-check. Yeah, it's a cross-check. So that's it, folks. We went through a lot of theory of operation on the fan system. We found some damaged relays. Matt helped me with the fan systems. So good thing Matt called out to power probe the fans and do a function check on them, because that led to discovering that we had bad terminals down there from somebody previously trying to diagnose it. I'm just going to say, hey, I messed up. I got caught up in my own theory and explanation and showing off test equipment that You know, I missed some of the obvious things, and that can happen when you go live unscripted. But realistically, be assured. I want you to be assured, okay? If Matt wasn't here and I moved forward with fan replacement and those fans didn't fix it, I would not be charging that customer for parts, okay? I would not be charging customers for parts. I do that with everything. If I recommend a part and I'm telling the customer I'm 100% positive this is going to fix your car, and I put it in and it doesn't fix it, I'm not charging you. That's not fair. Okay? That's robbery. I would never do that. You came in here for an AC concern and I said you need an AC compressor and your AC problem isn't fixed. Guess what? You're not paying for that AC compressor, and you shouldn't do that at other shops. It was misdiagnosed. Now, if there was a situation like I just had over here on this gentleman's car, okay, let's go over here. So this guy right here, he's got a 2012 Legacy, and he has a shuttering under acceleration. And he did pay for diagnostics. I did drive the car. I did verify the car, and I did check for codes. There's no codes. And from there, we did a throttle body inspection, and it was completely coked up, like layers of coke. I pulled out a spark plug. Spark plugs had like 1.1 millimeter gap on the spark plug, and spec is 0.8. So with that, I was telling him, I says, you know, we're showing a little bit of a misfire on the data log when we go out and test drive. We got worn out spark plugs and we have a coked up throttle body. We recommend that we catch up on some maintenances before we start condemning some other systems, because if your engine has a little bit of a hiccup, it's gonna multiply exponentially through your transmission, because that's what transmissions do. They multiply engine torque. So we needed to stick to that narrative of let's catch up on your maintenance because your maintenance is due. So we went in and we fixed up the spark plugs and we cleaned the throttle body. The guy bought spark plugs and he didn't want to clean the throttle body. I just did it anyways. Go out for a test drive, it's still doing it. But now I don't have misfires. So I can rule out that the engine is a problem, and now I can start diagnosing other systems. And when I did my data log, I could now trust the information that I was getting out of my data log. So let me show you here on the tool. So I had this information before, but I couldn't say that this was the problem because of the fact that we had misfires, all right? Because a misfire will make this same wave pattern here. So I'm data logging my lockup duty ratio, and I'm data logging my lockup solenoid signal, okay? So it's an on off signal. So when the orange line comes on, the blue line should go up. And we want to see a pattern like this right here. But this right here, this is the shutter. So that was present, but this can happen if you have a misfire because the lockup duty ratio is going to go down if you have any kind of small engine anomaly. That's what the TCM is programmed to do. And that's what had to be explained to the customer. He was a little agitated, but I was like, you know, we did the correct work, but now you're looking at a control valve body because we have a bad solenoid. And these are scenarios that you can run into when explaining diagnostics to people, especially on older vehicles, high mileage vehicles. You just got to get another system working so that way that you can trust the information coming out of another system. It's not always just one thing. So I want to thank everybody for participating in today's chat. And Matt, like I said, you're the hero today. A snap-on mantis. Jordan's asking for a snap-on mantis. Hey, thanks for the thumbs up, everyone. You know, Matt, that's you're very right. You know, it's really crappy because you're going in after somebody else, and you know, I don't get a lot of high mileage cars where other people have been going into them. From my standpoint, working in a dealership, I'm getting a lot of newer vehicles. So I would say about 65% of the cars that I'm diagnosing manufacturer out of the factory problems, okay? Um, Poorly built wiring harnesses, recalls, TSBs, but a high percentage of stuff that I'm looking at, we're doing like early, early component failure from manufacturer. And we're seeing a very small half of systems that are just completely worn out. Because most of the time, those people, they trade in their vehicles, and those higher mileage vehicles, we don't see them so much, and they go to smaller independent shops, or they just go to the crusher. Um, they just go to the crusher and we never see them. So that's why I always give like bigger kudos to people who are working in shops that have higher mileage vehicles coming in, because now you're dealing with multiple component system failure, because these are 150,000 mile, 200,000 mile vehicles. And you know, those higher mileage vehicles, they come with a lot of DIYers, and DIYers do things like we just saw down there. They front probe connectors and they spread the pin connectors so that way nothing settles up, nothing works correctly. But I say about one out of 100 cars come in with over 150,000 miles on them, and the only regular high mileage vehicles that I see coming into the shop, those are my customers from 10 years ago, and I've just been meticulously maintaining their vehicles over the last 10 years, and there's nothing wrong with them because they're up to date on all their maintenance. It's just very rare that we have high mileage vehicles that just come in out of the blue. Like they're finally just saying, oh, you know, like I'm just going to take it to the dealer now. And because I've given up on all these other shops, or I can't figure it out. So this is a scenario, this is definitely a scenario where we were the last resort, but we'll figure it out nonetheless. This was fun. This was a lot of fun. I'm glad I got to hang out with y'all today. But now it's Jim o'clock, and the little lady wants to talk to me. So fantastic. Thumbs up, guys.